Hi, my name is Chai Gao Fu. I'm from Faculty of Electrical and Electronic Engineering Technology. Now I will present my final year project FYP. So my final year project title is IoT-based fully automated smart parking system. And my supervisor is Encik Ahmad Izan. So first is introduction. So for introduction, smart parking system developed to allow the driver can check the availability of the parking slot and book the parking slot before entering the destination without wasting their time and fuel. So the purpose of this project is to design a smart parking system by using Arduino Mega, IR sensor, servo motor, LED, NOT MCU as communication device, and my TM inverter is the mobile application app, and Firebase as cloud. So the objective of this project is to design a smart parking mobile application that can be connected to the cloud. Second, to design and develop electronic circuit for smart parking system that can be controlled remotely. And third, to design a smart parking mobile application that user can preview and book a parking slot. Okay, next is the research methodology. We can see that here is the IR sensor, power supply, not MCU as the input of the microcontroller, which is Arduino Mega, and the output is servo motor, LCD, cloud, mobile application, and also LED. So next is the plot diagram for the transceiver model. So we can see here is the mono MCU goes to microcontroller, and last is the mobile application. Okay, next is the flowchart of the system. Okay, first you can see here is start, go to the system. We'll check the booking system, and wait if the parking slot is booked by the user, the yellow LED will turn on, and a gate will close, and will also go down. So this all will display on the mobile application. Okay, if the parking slot is not booked by the user, the system will scan the parking slot availability. So if the parking slot is occupied, the red LED will turn on. If the parking slot is free, the green LED will turn on. So all this will display on the mobile application. Okay, next is the result and discussion. So first, in this graph, you can is the average time response when 3 parking slots occupied immediately. So this graph is time versus internet speed. So as in conclude that the higher the speed of the internet, the faster the time response. So we can see for 100 maps is 2.31 second, 15 maps is 2.85 second, and last 22 maps is about 3.26 second. So the second graph is the accuracy of 3 IR sensors. So the accuracy of IR sensor, we can see that is all in 100%. So the way I check the accuracy is I put a obstacle in front of the IR sensor. When the obstacle detected, the red LED turn on. So when I tested, I found that the accuracy of IR sensor is 100% for 3 IR sensor. Okay, next is my prototype and also the mobile application. So this is a real-time status of the parking slots in project and also mobile application. So the result in these two is synchronized. So we can see here A3 the green LED turn on, and here also green LED turn on. So the A2 is red LED turn on because it has a vehicle in front of it. So the A2 is red LED. So the A1 is booked by a user because it is yellow LED turn on. So we can see here is the yellow, in mobile application the parking slot is occupied, okay. So the detail I will present in the demonstration part. Okay, next is the conclusion. In conclusion, this project presents a smart parking system which shows the real-time situation of the parking lot and enable user to check the availability of the parking slot. So user can also book a parking slot to reduce time in finding a free parking space in town area. Okay, next I will go to the demonstration part. So this is the demonstration of my project. So this is the initial status of my project. We can see here is there is no vehicle in front of the air sensor, so all present green LED turn on, and here present the green color, and also the LED shows A1, A2, and A3 is free. Okay, now I will put obstacle in front of the air sensor. Okay, you can see that the red LED turn on, and the LCD show that the A1 is occupied, and also here the A1 is also red in color, which means it is occupied. Okay, now I will show in A2 and A3. So the result is same. Occupied, the mobile application show red color. So A3 is also same. So now I will show you the booking system. So booking system is first we enter the if let's say we want to book the A1 slot. So we first enter the car plate and the A1 slot. Here the text box here. So we enter and press the A1 button. The booking is success. So if you did not enter a car plate number, a notification will come out. Now I will show you now. Okay, there is no vehicle number in the text box here, so an error will come out. So next I will enter a vehicle number 1234 for example. Okay, now the booking system, now the booking is success. So I have a notification that you have 15 minutes to reach the parking slot. So in this system I set two ways to cancel the booking. Okay, first is the time is 15 minutes. Your booking will be cancelled automatically. So next is the next I will present later. Okay, so the user have 15 minutes. So for this video I only set in 10 seconds. So we will see in after 10 seconds. And okay, now I present the next way to cancel the booking. If your driver reach the parking slot earlier, he can just here have a text box here. You can just enter the correct car plate number and press the get up button. The booking system will cancel automatically and the gate will go up and will open. Okay, now we wait for 10 seconds. Yeah. Oh, also the here show A1 is booked. Okay. Okay, after 10 seconds, the system go back to the initial condition, which is you can see the green LED light up, free, and also the A1 is green color. So next I will show you the second way to cancel the booking or to open the gate. Okay, now if the car plate here is empty, error will show. So now I enter the wrong car plate number. I enter 123 because that's now the correct one is 1234, right? Okay, now I enter the 123. Okay, error will show to the user which car plate error. Okay, now I enter the correct one. Okay, the gate will come out and the booking will be cancelled. So for the A2 is also the same. I insert 123. Okay, yellow LED turn on. The A2 show that it is booked. The gate go down. The gate close. So now I cancel the booking and let the gate open. 1, 2, 3. Okay, now there goes to the initial status. So now I will show that if there is a vehicle in the slot, the booking cannot be applied. So now we can see that the parking slot is occupied, right? Red occupied, red LED, and also here is red. Here show the red color. so the button will be unable to put the backing slot. So okay, so here same goes to A1. Okay, okay, that's all for my demonstration, and thanks for watching. Thank you.